slide after the lecture, and you that as your reference, note of reference, okay? But if you want extra, there's always extra things to learn. It's always in the books, yeah? Okay, let me just share my slide. Okay, so if you have any questions, you can interrupt, it's fine. If not, we'll just move from here. Let's see. Okay, so this lecture is going to be on connective tissue. You've had an intro to anatomy early in the morning, and also the epithelium lecture. Okay, we're going to continue with connective tissue. Now with everything, we need to know what are the learning objectives. Okay, you have to be able to describe the basic characteristic features of connective tissue and its components, right? And relate the components of connective tissue and its function. Okay, so there are four main groups of basic tissues that you have to know in the body that makes up your whole entire body. Okay, first is the epithelium, which we covered early this morning. So that would be on the cells that covers or that lines the body. And then you have connective tissue. So connective tissue is what we'll be talking about today. And then you have muscle tissues and nervous tissue. So this is the four basic components or four basic tissue that you have in your body. Now things like bones or blood, they're considered to be part of connective tissue, but they're the specialized kind of connective tissue. So you have a general kind of connective tissue and you have the specialized connective tissue, which is a connective tissue, but it serves a more specific function. Okay, so we're going to be looking at this type of basic tissue today. Okay, so connective tissue is a term applied to basic type of tissue of mesodermal origin. So later, when you go into embryology, you'll learn the terms, what is mesoderm, what is endoderm, what is ectoderm. So connective tissue, it's specific to the cells or the tissue that originates from the mesoderm layer. Okay, and what it does, it fills the spaces between organs and tissues. So your the organs and tissues in your body, you can't just have it suspended in the air. So it needs to have a layer or a place where it can embed itself. So that's what connective tissue is generally like. Okay, it's the most abundant type of tissue in your body and can be found anywhere. It can be found in your skin, it can be found in the abdominal cavity, in your organs, it can be found everywhere in your body. It's dispersed everywhere. And what it does, it forms a framework, okay, for epithelial tissue to rest on. So just now you've done epithelial tissue. If you look at the deeper to the epithelium, you find that there's connective tissue underneath that. Okay, it's also where the nerve and muscle would embed it. Okay, nerve and muscles are also a different type of basic tissue, and also for blood vessels and nerves to travel through, right? Like I mentioned earlier, the structures that you have inside your body, it cannot just exist like that, suspended in air. So it needs to travel through connective tissue, your blood vessels, your nerves, in order to go to a specific organ or to a specific area in your body. It needs to go through this connective tissue that helps to hold it up, to form a network for you to form a framework, a scaffolding for you to put things on, sort of like a shelf kind of, in a way. Okay, so depending on the type and the makeup, the cellular makeup, it can serve many different functions. Okay, for one, it can be a support. Okay, it can help to support like your bones or your tendons and ligaments. It helps in the support of your body. It can be a defense kind of function. Okay, it can be the physical defense, like the way the cytoplasm is made up of, or the ground substance. It can be a physical kind of barrier, or it can be an immunological kind of barrier. So if you have a specific cell that can produce antibodies, cells that can produce other type of substances that can play a big role in your immune system. Okay. Also, it can help to repair your body, for storage, especially if you're talking about adipocytes. Okay, there's a lot of energy storage in there, and also nutritional as well. So it serves a varying array of functions, but and it all depends on the type of connective tissue you're talking about or the cellular content. Okay, so if I've done all this, okay, now we're gonna look into the origin of your connective tissue. As I mentioned earlier, it's from your mesoderm layer or the mesenchyme. So this mesenchyme is tissue that is formed by the mesenchymal cells, which is the cells that originate from the mesoderm layer of your embryo. Okay, and when in during the embryological process, these cells, these mesenchymal cells, will migrate all over the body to surround and penetrate developing organs. So that's why you can find connective tissue everywhere in your body. Okay, so connective tissues are made up of three things. Okay, the cells, the cellular component. So you have different kinds of cells that make up the connective tissue. You have adipocyte cells, you have fibroblasts, you have macrophages. So these are all the different types of cells that you have that make up connective tissue. But you also have what is known as the extracellular matrix. So the extracellular matrix are made up of two things, fibers and ground substance. So fibers, mostly what we're going to be talking about is fibers like collagen fibers or elastic fibers. Sometimes you have what is known as reticular fibers. So these are different fibers with different kinds of function and also characteristic. And then you have the ground substance. So ground substance are what fibers and cells are embedded in. Okay, they're like ground substance like your glycose, aminoglycans. Later we'll be looking at that as well. So cells are, so say you have like a bowl of soup, right? So you have the cells, which are your potatoes, and then the extracellular matrix is the ground substance. So you have the soup itself, the fluid, that's your ground substance, okay? And the fibers would be sort of like your noodles, okay? So these are all what the chicken and your potatoes and your carrots need to be suspended in something. So that's your extracellular matrix. Okay, your fibers, which are like kind of like noodle-like things, and then the ground substance, which is the fluid itself, the soup itself. Okay. So in normal basic tissues, right, the cellular content is very, very high. So you have a lot of cells as opposed to extracellular matrix, right? So you have a lot of chicken, a lot of potatoes, but you have very little minimal fluid, very minimal noodle. But in connective tissue, you have a lot of extracellular matrix with little cells. Okay, not so little, but the extracellular matrix is more than the cell itself. Okay, and this is specific to connective tissue. It's something that's quite peculiar with connective tissues. All right, is made out of cells, fibers, and ground substance. We'll be looking at each of those components individually. So we're going to be talking about the different cells that make up your connective tissue, and then we're going to be going on to the fibers that you have and the ground substance. Obviously, we're not going to be able to cover everything, but these are the main major or the most significant kinds of cells, fibers, and ground substance that you have in your body. Okay. So for connective tissue cells, you can further divide it into two classification. Either it's a fixed or intrinsic kind of connective tissue. That means it's fixed to a certain area or fixed to a certain organ or fixed to a certain region. It doesn't go everywhere in your body. Or you can have what is known as an extrinsic connective tissue cells. So extrinsic tissue cells will be also known as wandering cells, where it can go everywhere in your body. Okay, fixed cells are like your adipocytes. Okay, your fat tissue, your fat cells. They're fixed at a certain place. You don't find it wandering around. But extrinsic is like your leukocyte or your macrophage. They can move around in the bloodstream. So that's why it's also known as wandering cells. Okay. All right. So as I mentioned, fixed you have is a resident population. It doesn't go anywhere, and it develops and stay within the certain connective tissue. The types of fixed cells that you have are fibroblasts, adipose cells, and also undifferentiated mesenchymal cells. So we'll be looking at it more specifically into all these cells. Okay, but for the free extrinsic or wandering cells, they originate from the hematopoietic cells. They originate in the bone marrow itself, and it, as I mentioned, it will circulate in the bloodstream, so it can wander everywhere around in your body. And it will, as it was wandering, it will just stay as it is. It doesn't form any function. But then if you have like a certain problem, okay, so you have a proper stimulus, the wandering cell can migrate into connective tissue to perform its function. So let's say if you have like something like free macrophages, wandering macrophages, okay, it detects that you have an infection, then it can travel out of your bloodstream to go to that specific area where you have the infection, and it will help to lyse whatever pathogen that you have. Okay, so it's sort of like a policeman that's doing its round. Okay, and when you have a problem, they will go to the certain area and will perform its function. Okay, so there are certain types of free or wandering cells that you have. You have the free macrophages, you have plasma cells, mast cells, and then all the four below that will be part of your white blood cell. Okay, neutrophils, eosinophils, basophils, and monocytes. Okay, so now we're going to look at the specific cells that we have, right? In the fixed or intrinsic cell category, you have fibroblasts. So fibroblast is a type of intrinsic cell, okay? Or it's fixed, that means it doesn't go anywhere. It develops and it will mature in the specific area itself. Okay, so it's the predominant connective tissue cells. You have a lot of fibroblasts in your body. And what it does, it synthesizes, secretes, and maintains major components of extracellular matrix. So remember, your connective tissue, you have cells, but you also have extracellular matrix, which includes your fibers and your ground substance. Okay, so what this fibroblast does, this fibroblast helps to produce a lot of the extracellular matrix. The fibers, the ground substance are actually synthesized by the fibroblast. So if you have any injury that occurs, okay, like if you have a wound, okay, what helps to cover that wound, what helps to fill in back all the spaces that are left behind by a wound is your extracellular matrix. So the fibroblast will help to synthesize this extracellular matrix to make sure that you have you heal back the wound. All right, and you have two kinds of you have an active or a quiescent fibroblast. So if it's quiescent, it's known as fibrocyte. Okay, fibrocyte is the more mature, already retired kind of cell, but the fibroblast is active. It has very long and stellate cytoplasmic processes. It has a large and ovoid pale-staining nucleus, so it's very metabolically active. You have a lot of rough endoplasmic reticulum, Golgi complexes. These are important in protein synthesis. But in quiescent cells, in fibrocytes, they've done their part earlier on in your life, so they're going to chill out a little bit. They have smaller cytoplasm. The nucleus is a darker, smaller, and you don't have that much organelles. Okay, not many cytoplasmic organelles. So this is sort of like the difference that you can see. Fibroblasts, they're clumpy, they have more things going on, but fibrocytes, they're going to be chill out a little bit. Okay, so they don't have a lot of R of ER, they don't have a lot of Golgi complexes, they're not quite as active as your fibroblasts. Okay, so if you were to take a slide of the connective tissue, the ones that are highlighted by the arrow are your fibroblasts. Okay, and you can see the fibroblasts surrounding it. There's a lot of fibers around. Okay, that means the fibroblast is actually actively synthesizing fibers, actively making up fibers to maintain or to help heal the surrounding connective tissue. Okay, so that's fibroblast. That's what it does on most parts. So majorly, it synthesizes, secretes, and maintain major components of your extracellular matrix. Okay, So now we're going to look at another type of fixed cell. Okay, so adipocyte is also fixed. It doesn't go anywhere. It doesn't travel in your bloodstream. Okay, so these are adipocytes. They're also known as fat cells. The more scientific, more accurate way for you to name it is adipocytes. We're specialized as storage depot for lipids. Okay, and it's scattered singly or in groups in loose connective tissue. So sometimes you can find it along blood vessels. It helps to insulate the blood vessels as well. And when the adipocyte predominate the connective tissue, it's called as adipose tissue. So when you have a connective tissue, but you have a lot of fibroblasts, a lot of other cells, except for, but you do have a little bit of adipocytes. You don't call it adipose tissue. You call it a different kind of connective tissue. But when you have a connective tissue that's mostly made up of adipocyte, then you can call that connective tissue adipose tissue. Okay, and the adipocyte, you have a specific appearance to it called a signet ring appearance. So if you've ever seen like noblemen, if you ever watched the movie Kingsman, you know, a lot of British noblemen, they like to wear a signet ring on their little finger, on the left, a little finger. So it looks like a normal ring, but you have like a big signet area there. Usually in days of old, you know, you don't sign your name. What you do is you have a special logo on top of the ring, and when you can put your stamp on your letters and things like that. So anyway, it's called a signet ring appearance. We'll be looking at the cells later. Adipocytes, you have two kinds. You have a white adipocyte and you have a brown adipocyte. Okay, so if I just go right, so white adipocyte in the middle. If you do a slide, okay, so you prepare a H&E slide, it appears as empty cells because the lipid inside the cell has been dissolved during tissue preparation. So you only are left with the cell wall. Okay, and white adipocyte, they store the lipid as a single large droplet. So sometimes white adipocyte is also known as unilocular adipocyte. Okay, whereas brown adipocyte, they're smaller, not as big as white adipocyte, and they have a lot of lipid droplets in the brown adipocyte, in the cell itself. So they call it multilocular. That means you have more than one droplet of lipid storage. Okay? And a lot of brown adipocytes are found in newborns, so in babies, in infants, in neonates, they have a lot of brown adipocytes. Because these brown adipocytes, they help to generate more body heat. Okay, and the nucleus for adipocytes are eccentric. That means it's pushed to the side. And with brown adipocytes, it's brown in color because of the number of mitochondria that you have. So if we were to look at this picture here, on the right here is white adipose tissue, and on the left here is your brown adipose tissue. So you can see that, well, it's brown in color for one, but it's not going to be as big as your white adipose tissue. Okay, so this white adipocyte here, you can see in the middle, it has pretty much nothing. Okay, that means it used to store lipid in here, but when you process the slide, when you want to prepare the slide, the lipid inside here has been dissolved. Okay, so it's been washed away. So you're only left with your cell wall, and you can see that the nucleus is there. So one adipocyte with the nucleus, another adipocyte with the nucleus. Okay, so this is called your unilocular or white adipose tissue. And on the left here will be your brown adipose tissue. You can see you have multiple small little droplets of what used to be droplets, okay, but it's been washed away by preparation, and it's brown in color because of the number of mitochondria that you have in the brown adipose tissue. So that's why it's the brown adipose tissue are able to generate body heat because you have a lot of these powerhouses, your cellular powerhouses, your mitochondria. So it's very important in a newborn because they can't really do it on their own. So they have this sort of like passive kind of insulation for them to be able to live comfortably. Okay, and another type of fixed connective tissue cells, okay, is your mesenchymal cell. So mesenchymal cells, they're unspecialized. Okay, remember, all of connective tissue actually comes from mesenchymal cells, which comes from your mesoderm layer. Okay, so mesenchymal cells, they're not yet they haven't commit themselves to the different kind of uh, descendants that you have. Okay, so mesenchymal cells are undifferentiated, unspecialized, and they're able to later on they can differentiate into different cell types. So sometimes, if you need fibroblasts, they can change into fibroblasts. If you need osteoblasts, they can go to commit themselves to be to the osteocytic line. Okay, so they serve as a potential source of cells for replacement and repair of connective tissue. All right, so those are your the three examples of your fixed cells, your fibrocyte, your fibroblast, depending whether it's active or it's quiescent. And then you have the adipose tissue. So you have adipose cells, sorry. Adipose cells can be either white or brown, okay, depending on the type that you're talking about. And you have mesenchymal cells. These are all fixed in a certain organ. So that means it penetrates that organ and it stays there, it develops in there itself. Okay. Now we're going into the one ring cells or extrinsic cells. Okay, but specific to macrophage, it can either be fixed or it can also be wandering. So macrophage, they have special property because usually they would be fixed they would be wandering in your bloodstream, but sometimes they go to specific organs when they will stay there and it will carry out its function there. So we're looking at that specific types of fixed macrophages where you have the specific name depending on where it is. Okay, we'll be looking at that in a bit. Right, but macrophage itself is derived from cells of the blood monocyte lineage, and it will infiltrate connective tissue and develop into phagocytes. So for the wandering cells, they would go all over in your body, in your bloodstream, or whenever you have like an infection or a pathogen comes inside your body, so it will infiltrate into the connective tissue and will develop into a phagocyte. Now, when it becomes a phagocyte, what it does, it has this very large cytoplasm. Okay, it has one single nucleus, and it has in its cytoplasm the organelles that's quite important in macrophages is they have a lot of lysosomes and well-developed Golgi complex. Okay, so lysosomes help to lyse things, and the Golgi complex helps to is important in protein synthesis. Okay, and also macrophage it exhibit what is known as chemotaxis. So it will chemotaxis means it will attract other phagocytic cells. Okay, so when one macrophage finds that you have a pathogen here, then it will exhibit its chemotaxis ability. So chemo means it has its substance that it will release to attract other phagocytes to come, other macrophages that has turned into phagocytes. So if it's able to call more phagocytes, then it will fuse together with other kinds of phagocytes and form what is known as a multinuclear giant cell, and will be able to remove large foreign objects or large pathogen. Okay, so this is an example of a macrophage that is turned into a phagocyte. Okay, phagocyte is when it wants to eat something. Okay, it wants to phago means eat, sort of like swallowing, kind of eating. Okay, and cyte is a cell, so it's an eating cell. It helps to eat up all your pathogen, the foreign substance. Okay, so the cytoplasm itself can have variable kinds of shape, okay, depending. What is important is you have a lot of lysosomes. So lysosome will produce enzymes that can lyse all of this foreign substance. And the cytoplasm will form pseudopodia, okay, your fake feet, where it will engulf your materials. So when you have the materials engulfed inside the cytoplasm, then a lot of your Golgi complex, your RER, whatever that is important for protein synthesis, will release enzymes so that you can eat up all your engulfed foreign body. Okay, and remember it has this chemotaxis ability, so it can fuse with other phagocytes to form multinuclear giant cell to remove bigger foreign objects. Right. So your macrophages, they can be, like I mentioned earlier, they can either be wandering or they can be fixed. If they're fixed, they have specific names depending on where it sits. Okay, if you find macrophages in the liver, they're known as Kupffer cells. If you find macrophages in the central nervous system, they're known as microglial cells. In the skin, you can also have macrophages. They're Langerhans cell. And when you look at in the bone, it's known as osteoclast. So osteoclast especially, it helps to remove your bony material. Okay, so osteoclast versus osteoblast. We'll be looking at that when we look at bone tissue in a different lecture. Okay, so this is just a phase of phagocytosis. I just put it here so that you can make sense of, okay, you know what is the function of macrophages. You know, when you know the function, it's easy for you to know what does it look like, or what organelle is important that's for it to have an abundance of, like, you know, a lysosome. Okay, so far okay with your macrophages? Any questions?
No, doctor.
No, yeah. Very solemn no, but it's okay. We'll move on to mast cells. Okay, we have a few extrinsic or wandering cells that we need to cover. Next is mast cells. So mast cells, they're large oval or round cells. Okay, they have a nuclei, but it's small and spheroidal in shape. But what is most important about a mast cell is that it has an abundant basophilic cytoplasmic granule. So basophilic means that it appears purplish blue. Okay, so when you do a HNE stain, hematoxylin and eosin stain on specific parts of your body, thank you. You can have either it is basophilic or eosinophilic. So eosinophilic will appear pink or red, and basophilic will appear more blue or more purple. Okay, and what you have in a mast cell is you have a lot of this bluish, purplish cytoplasmic granules. So granules that is living in the cytoplasm. Okay, and mast cells are very important in inflammatory reactions and immediate hypersensitivity allergic reaction. Okay, so allergic reaction, you can either be immediate or delayed. So mast cell is plays a very significant role in the immediate kind of hypersensitivity reaction. All right, and what it has and what it does, it will release a lot of histamine, a lot of, thank you, eosinophilic chemotatic factor, and heparin. So all of these are actually stored in these granules, in the basophilic granules. Okay, once it has proper stimulus, they will release all these substances: the histamine, the eosinophilic chemotatic factor, and also the heparin. Okay, let's have a look at the mast cells. Okay, so you can see that is one cell over there. Okay, and that's the nucleus in the center, and all of this is the cytoplasm. So cytoplasm should appear lighter in color, shouldn't it? But you can see that it's actually all of what that you can see here. The purple color is the granules that it has, the basophilic cytoplasmic granule. Okay, so a lot of it in the cell, and this is where you store all your histamine, heparin, eosinophilic chemotatic factor. Okay, very important in immediate hypersensitivity reaction. All right, so mast cell is that, a lot of granules. Okay, and then next you move on to plasma cells. So plasma cell is derived from your B cells, your B lymphocytes, and it produces circulating antibodies. So it's also important in your immune system. Okay, abundance in areas that are susceptible to penetration by bacteria. It's large and ovoid cells, and this is its what is peculiar about plasma cells. It has this eccentric nucleus, all right, and for the nucleus, you have a large central nucleolus. So nucleolus appears in the middle, and then surrounding this nucleolus is that you have this hematochromatin clumps, and this hematochromatin clumps are spaced so that it surrounds your nucleus in a way, in a specific way. So you have the nucleus, okay, so that's the nuclear envelope, and in the middle you have your nucleolus, and then you have this hematochromatin clumps that space regularly. Okay, so what it does, it looks somewhat like that, and this is what is known as a clock face appearance. All right, so plasma cell also has a lot of rough ER. That means you know that it's going to be important in, you have a lot of protein synthesis occurring. So this protein synthesis, what it's what protein synthesizes is your antibodies. Okay, so if I just show you a picture of your plasma cell, you can see this is your nucleus. All right, that's your nuclear envelope in surrounding the nucleolus, and then these are your hematochromatin clumps. So you space it regularly, and it looks like a clock face. Right. So if I were to show you a slide of connective tissue, you can see these cells here. These are all your plasma cells. So plasma cell, plasma cell, another plasma cell there. And you can see the nucleus there, right? The midline will be your nucleolus, and these are your hematochromatin clumps, regularly spaced in the nucleus, and it gives the nucleus and also gives the cell in a way a clock-like appearance, a clock face appearance, and you can easily identify the plasma cells. All right, next cell that wanders around in your body is your leukocytes. So leukocytes are your white blood cells. You have different kinds of white blood cells. You have neutrophils, you have eosinophil, you have monocytes. Okay, so it looks different depending on the cell that you have, but I'm not going to touch this too much because you'll be learning a lot about leukocytes in later blocks, especially in hematology. Just know that you have different kinds of white blood cells. All right, and it can look differently. It has a different kinds of shape. So these are all the cells that we've talked about mostly. So fibroblasts, okay, bigger, longer cytoplasmic extensions. Okay, fibrocytes, quiescent, they're retired, so they're older and they don't have as much as activity going on. So plasma cell, that's your plasma cell with the nucleus, with the central nucleolus and hematochromatin clumps regularly spaced around, giving it a clock-like appearance. Okay, that is your mast cell. So mast cell, they have a lot of granules around it. And this is your adipose cell. Okay, you can see a signet ring appearance. It appears empty in the middle because the lipid has been washed away during preparation of the slide, but you can see the nucleus that has been pushed to the sides. Okay, so this is a sort of like an overview of everything that we've talked about. Right, so we've talked about the cells. You know now that you have multiple kinds of cells. You can divide it into intrinsic and extrinsic cells. So intrinsic cells, you have fibroblast, fibrocyte, adipocyte, and mesenchymal, okay, and differentiated mesenchymal cells. And in wandering, but you also have some fixed macrophages as well. Don't forget about fixed macrophages. Like in the liver, you have Kupffer cells. In the skin, you have Langerhans cells. And then for wandering cells or extrinsic cells, you have your mast cell, plasma cell, wandering macrophages. Okay, you have your leukocytes. So I hope that helps to entangle the cellular part of the connective tissue. Now we're going to talk about the fibers and the ground substance. So fibers, we're going to mostly talk about three types of fibers, which is the elastic, collagen, and reticular. Okay, so that will form a part of your extracellular matrix. So now we're going to look into fibers. Okay, so fibers, they're long, slender protein in connective tissue. Okay, you can categorize them in collagen, elastic, and reticular fibers. And of course, collagen, you're going to have like multiple subdivision to different types of collagen, 2A, 2B, but you don't have to be bothered by that. You just have to know collagen in general, elastic in general, and reticular fiber, which reticular is actually part of your collagen. We'll be looking at that later. So collagen is the most numerous kind of fiber that you have in your body, and you can find it a lot in tendon, in joint capsules, and in ligaments, and it provides a lot of tensile strength. So collagen fibers are quite strong. Okay, and that is the characteristic of collagen fibers is that it provides strength to the connective tissue that you have. So if you can see, this is a connective tissue, and you can see this part here. These are all the collagen fibers, long, slender collagen fibers. To move on a little bit, okay. Sometimes collagen fibers, they can occur in large or small bundles, or even individually, but more often than not, it will occur in bundles. So this here is a bundle of collagen fiber. another bundle of collagen fiber, another bundle of collagen fiber here. So you have certain bundles are a bit bigger than another bundle. Okay, certain bundles are a bit smaller. So the one that's lighter in color here, these are all your collagen fibers. Okay, and again, acidophilic stain. So it will be lighter, kind of like reddish appearance, reddish pink appearance to it. Okay, so these are your collagen fibers. Next fiber is reticular. Reticular is reticular fiber is technically a kind of collagen fiber. It's a collagen fiber type 3. But again, as I mentioned, you don't have to know the types, the different types of collagen fibers. It will be a bit too complicated. So you know that reticular fiber, we can just call it by itself. But it is a subtype of collagen fiber. Reticular fibers, they're very thin fibers, and it helps, it is important in structural maintenance of hemopoietic organs. So you find it in lymph nodes, in the spleen, so things that are related in the hematopoiesis especially. And it forms what extensive networks. Okay, it doesn't form bundles like your normal collagen fiber does. It forms networks, so it forms sort of like a net kind of appearance, and it's special because it's stained by silver salts. So the if you want to see reticular fiber clearly, you have to stain it with silver salts as opposed to just normal H&E staining. So as I mentioned, it's important in hemopoietic organs. So you find it spleen, lymph nodes, bone marrow, certain endocrine glands as well. So these are your reticular fibers. It doesn't occur in bundles, so it's singly, but it forms network. Right. So you were to look at a section of your lymph node as well, you can see that you see the thin hair-like nets. These are all your reticular fibers. Okay. Now the third fiber, the final fiber that we're going to be looking at is elastic fiber. So elastic fiber, it has proteins called elastin and microfibrils, and they're rubber-like. So by its name, elastic fiber, you know that it is able to stretch and contract. So in a rubber-like um, manner, okay. And it has short branching fibers forming irregular networks. So it's somewhat like reticular where you have network, but it doesn't form a very tight network. Okay, so elastic fibers is important in things that need stretch. So like the big arteries in your aorta, especially where it needs to be able to expand and contract. In your lungs, and also you find it in ligamentum flavum of your vertebra. Okay, so if you want to look at this picture, this is a picture of a loose connective tissue and areolar connective tissue. Okay, the one that has this long single hair-like thing, these are your elastic fibers. Okay, they're darker when they stain darker. Okay, the ones that's lighter, reddish pink. Okay, with thicker bundles. All right, these are all your collagen fibers, and interspersed between them, these are all your cells. If you find there's a cell, there's another cell, as a different cell. Okay, so this is a type of connective tissue known as loose connective tissue, where you find multiple types of fibers and cells embedded in it. Okay, again, this here would be the elastic fibers. So it doesn't have a certain arrangement to it. Again, it forms this irregular network. Okay, so these are thin-like structure here, all the elastic fibers. And if you see in the background, okay, it's not being focused on, okay, but these are your collagen fibers. Okay, so you can lighter color. I have bundles, thicker bundles, thinner bundles. These are all your collagen fibers. Okay, I think that's all for fibers. So we've done cells, we've done fibers. So fibers, you have three, okay, collagen, reticular, and elastic. And then cells, you have your fixed and wandering. So you have multiple underneath that, so you have to know. And then for the ground substance, we'll be talking about it. It doesn't really, it's quite important, of course, but I don't want to go into the different molecular level kind of explanation for ground substance. So just know that ground substance, they're amorphous materials surrounding cellular and fibrous components. They're sort of like if you have like a cell, right? So there's the cytoplasmic part. Okay, so ground substance is kind of like that. They're amorphous, they don't have a shape. Okay. And it's made up of highly hydrated, transparent, complex mixture of macromolecules. So different kind of macromolecule will give you different kinds of ground substance. Okay. They're synthesized by primitive mesenchyme, all right, by fibroblasts, by chondroblast, osteoblast, depending on where it's located. Okay, and it can be very thick. Okay, the material can be quite viscous, or it can be very loose, depending on the amount and type of the glycose aminoglycans that you find in the ground substance. And what it does is it acts as a lubricant or a barrier. And how it acts as a barrier is if you have a very thick, very viscous ground substance, then it's very difficult for foreign substance to penetrate through. Okay, so if you're trying to walk in water, right, it's easy for you to walk because it's very loose, it's not viscous. But if you try to sort of like, have very muddy waters that you need to traverse through, and then it's very difficult for you to walk from one end to the other. Okay, so this viscosity helps to provide a barrier for ground substance, for foreign substances to travel through, right? And this is the function of your connective tissue, the physical barrier that it can provide. It's not that you can't pass through at all. It's just going to slow it down a little bit more. Okay, so brown substance can be, you have different kinds of, these are all your macromolecules that would make up the ground substance. So either glycosaminoglycans, or proteoglycans, or multi-adhesive glycoprotein. Okay, all right. So done with the component part of the connective tissue. So connective tissue components, you have your, remember, cells, fibers, and ground substance. So these two will form your extracellular matrix. Okay, so these are the components of the connective tissue that you need to know. Okay, the cellular component, the fiber component, and the ground substance component. Now we're going to be looking at different kinds of connective tissue. Okay, so here we look at it in a more smaller level, in a more like cellular level, and now we're going to look at it in a more connective tissue, the tissue kind of level. Remember, a lot of cells make up tissue. So this is the classification that you can have. So connective tissue can be divided into embryonic connective tissue or adult connective tissue. So embryonic will only, this connective tissue will only occur during pregnancy, okay? In the antenatal period, you either have a mesenchyme connective tissue or mucus-like connective tissue. And in us, okay, in all of us, we find the adult connective tissue. So you have loose, dense, and dense can be divided into dense irregular or dense regular. And you have specialized connective tissue, reticular, adipose, you have your bone tissue, you have your cartilages. So that's more of a specialized kind of connective tissue. But what we're going to look at is we're going to look at this classification. Okay, so first, embryonic, mesenchyme and mucus. Mesenchyme only present in embryo, so only present in the antenatal period. Okay, and it consists of mesenchymal cells in ground substance containing scattered reticular fibers. So you can see all of these cells here. These are your mesenchymal cells. Remember, mesenchymal cells, they are undifferentiated. Okay, they come from your mesoderm layer. They're undifferentiated. They haven't yet decided whether they want to be bone, whether they want to be fibroblasts, whether they want to be osteocyte. They haven't decided yet what they want to become. Okay, this your sort of like a stem cell kind of thing, and it's going to be embedded in this ground substance that have reticular fibers. Okay, so the cells are oval nucleus with prominent nucleoli, and they're very sparse. The cytoplasm is pale staining and very sparse. So you don't have a lot of cytoplasm, and it's very light in color, so it's very difficult to see it. And because it occurs in your embryo, so you can see a lot of mitotic figures. They're still undergoing mitosis. Okay, immature kind of connective tissue, because it has not yet, it's still dividing and it hasn't yet decided what it wants to be. Okay, next will be the mucous connective tissue. This mucous tissue you can find small number of cells, but a lot of ground substance. So the extracellular matrix is significantly more in this kind of tissue, in your mucous tissue. The cells in it, not many, okay, mostly a lot of cells just to be able to synthesize the ground substance. Its function is that it's able to yield to pressure, but it can return to original shape. So that's more of what mucous tissue is supposed to be like. It's not involved in replication. Okay? It's not dividing still the cells. What it's supposed to be is that it's supposed to provide sort of like a cushion to certain important structures. Okay, so mucous tissue will have this jelly-like consistency, and it as I mentioned, it's supposed to be able to protect structures from pressure. Okay, so you find it in umbilical cord. You can, they call it the Wharton's jelly. Okay, so and also you find it in nucleus pulposus of the intervertebral disc and pulp of young teeth. Okay, so this is an example of a mucous tissue. So this here is your Wharton's jelly. This actually is the umbilical cord itself. So you have the two arteries and one vein, and then surrounding it is the Wharton's jelly. So Wharton's jelly, the mucous tissue, remember, is able to yield to pressure. So whenever blood goes through your vessels here, it's able to allow the expansion of the artery or the expansion of the vein, but then it will come back to original shape, and it will be able to yield excess pressure from external as well, so you'll be able to protect these vessels. Okay, so that's your mucous tissue. Mesenchyme and mucus in embryological connective tissue. And now we're going to adult connective tissue. Any questions thus far? Any problems? Do you want any breaks? No? Everyone
No,
okay?
doctor.
Oh,
Yes.
doctor.
Okay. So we're just going to cover a little bit on the adult connective tissue, and then we should be done with the lecture. Okay. So adult connective tissue, remember you have loose and you have dense connective tissue. Okay, so we're going to look at loose first. Loose connective tissue is also known as areolar connective tissue. Okay, it's very common in the body. You find it in a lot of structures, okay, in a lot of areas in your body as well. What it does is it supports structures under pressure and low friction. Okay, it supports epithelial tissues. It will surround blood vessels, lymphatic vessels, nerves even, and it will fill spaces between muscles and nerve fibers. It's sort of like your filler. You know, if you want to post something up to people, you put your bubble wrap around it. Okay, so this is also sort of like that. It helps to fill the spaces in and around special structures. Okay. So specifically, you find it in the papillary layer of the dermis. I hope you know that dermis will have different layers, or if you don't know yet, you'll have a skin lecture soon. So in the papillary layer of the dermis will have papillary and reticular layer. So the papillary layer is the most superficial layer. All right, and then you find it in the hypodermis, in the peritoneal, pleural cavities, mucous membrane. So you find it in a lot of spaces, all right? And what you have that makes up the loose connective tissue is your fibroblasts, you have macrophages, you have collagen, you have elastic, and you have few reticular fibers as well. They're delicate and it's flexible and well vascularized, and you don't have any organization to it. It's very loose, no organization, sort of like a little chaotic in nature. Okay, so that is what example of a loose connective tissue would look like. Okay, no fibers, they don't have any organization to it. You have some blood vessels sometimes if you look through certain areas, and you find that all the fibers will run in random. Okay, mostly you find collagenous fibers. So the one that occurs in bundles here are collagenous fibers, but you also have elastic fibers interspersed between the collagen fibers. So the long ones here are all your collagen fibers, and you can see that you have a lot of cells. See this cell here? That's a mast cell. You can see a lot of granules, the basophilic granules. So this here is actually a mast cell. You can also find another mast cell here. Okay, a lot of the other fibers, okay, a lot of the other cells, sorry, especially if it's interspersed between fibers, it's your fibroblasts that's synthesizing the fibers here. Okay, so this is a type of connective tissue known as loose connective tissue or areolar connective tissue. No organization. You have collagen, you have elastic fibers in it. You have, fibroblasts, you have mast cells, you have all kinds of cells in it. Sometimes you can see blood vessels running through it. So this is your areolar or loose connective tissue. Okay. And then next, we'll be looking at dense connective tissue. So dense connective tissue, you have two types. It can either be dense regular or dense irregular. Okay. And dense connective tissue, it offers more resistance and protection. Okay. You have same components as loose connective tissue, but you have fewer cells. You have a lot more fibers in dense connective tissue. Okay. So loose is very loose. There are not a lot of fibers. But in dense connective tissue, you have a lot of fibers, making it very, very dense. Okay, you don't have a lot of space in between it. Right? So dense, you can have dense irregular or dense regular, depending on how the fibers are organized. Okay, so if the fibers here are organized haphazardly, it has no uh, nice pattern to all the fibers, is known as dense irregular. So the collagen fibers are arranged in bundles without any orientation. Okay, and all the collagen fibers are packed tightly. Okay, and you can see some elastic fibers that will be present, scattered around, and it's found in the dermis of skin, in the sheath of nerves, capsules of your organs, in the spleen, capsule of the spleen, capsule of the testes, of the ovary, kidney, and you also find it in the capsule of lymph nodes. Okay, so this is what a dense kind of irregular connective tissue will look like. Okay, so you have a lot of fibers. You can see all the fibers, but all the fibers are arranged haphazardly. There's no nice organization. Okay, sometimes if we look at fibers that are arranged, you can have a very nice organization like that. But this one, you don't have that. Okay, and you can find it in this is a slide of the skin. Okay, that's a dermis of the skin, especially the reticular layer. Up above here is the papillary layer, which is where your loose connective tissue is found. Okay, here's your loose connective tissue, and the reticular layer is your dense, irregular connective tissue. And why is it located in the skin, underneath the skin, is because your skin is going to be moved, or you're going to have pressure that you'll be taking, going onto your skin from all different directions. So you have fibers that are arranged one way, and then you have a pressure that's going to be exerted on it in another way. It can actually, you have this shear force that will break all these fibers. But because it's organized, or rather it's not organized, okay, you have fibers going haphazardly, so you can take shear forces from everywhere, and that's what your skin is, daily, on a daily basis. That's why your skin goes through. It's going to be moved from all kinds of direction. Okay, so that's why you have underneath your skin dense irregular connective tissue. If you have it in a regular pattern, it will not work. Okay, so again, another picture where you have fibers going all everywhere. He's just a bit chaotic, but it serves a function. All right, and then you have dense regular. So in dense regular, you can either have dense regular collagenous or dense regular elastic. So you can see here, all of the fibers are arranged in very nice pattern in one direction. Okay, everything looks nice. Everything, the fibers are all parallel to each other. It looks very neatly organized. Okay, this is your dense regular collagenous because it's made up of mostly collagen fibers. Okay, so you have a lot of collagen fibers that's arranged in definite pattern. Okay, you can see some fibroblasts interspersed in between because you need fibroblasts to be able to synthesize these fibers. Okay, they're tightly packed. You don't have a lot of ground substance, not a lot of your glycosaminoglycans, okay, because most of the space is going to be taken up by the fibers. So most common examples of your dense regular collagens is in your tendons and ligaments. Okay, because muscle works in one direction. So your tendons and ligaments, the tendons especially for the muscle, it needs to only be able to uh, uh, resist force in one direction. So the fibers can be arranged parallel to each other, can be arranged in one direction. Okay, and ligaments also, most of your ligaments that connect between bones and bones will only need to resist force from one direction. So you have it in a dense, regular collagenous because it's made up of a lot of collagen fibers. And then, of course, you have your dense, regular elastic, where you have a lot of elastic fibers packed very densely, and it's all arranged in um, uh, one direction. So everything is arranged parallel to one another, and you find this in blood vessels, in the ligamentum flavum of the vertebra, and also you can also find it in the suspensory ligament of the penis. Okay, so dense regular elastic is this is how it looks like. A lot of fibers all arranged in one direction parallel to each other, and you have a lot of elastic fibers. So elastic fibers, remember, it's darker staining than your collagen fibers. So this is your collagen fiber. Okay, you can also see your collagen fiber here arranged parallel to each other, and then that's your elastic fiber. So dense regular elastic, dense regular collagenous, and irregular dense. Okay, dense irregular, right? And with a loose here. So that's the four that we've talked about: loose connective tissue, papillary layer of the dermis, irregular, dense connective tissue, reticular layer of the dermis, and then you have your dense regular collagenous and dense regular elastic. Okay. So if you when you do your revision, you can look through the notes. Make sure you look through the pictures properly, and it can all make sense to you. All right, so now we're going to specialized connective tissue. We're not going to talk a lot about specialized connective tissue, reticular, adipose, and I think, yeah, just reticular adipose, a little bit of the blood. Okay, for supporting connective tissue like cartilage and bones, we're going to have a special lecture for it because it's quite important. Right, so reticular connective tissue, just when we talk about the reticular fibers just now. So reticular connective tissue is made up of the whole thing here. You're going to have reticular fibers that forms your network, okay? It forms a scaffolding for where the macrophages will be, the fibroblasts will be, and it's very, you find it usually in hematopoietic tissues, your bone marrow, spleen, lymph nodes. Um, and it helps to support these cells, and it helps to filter as well body fluids. Okay, there's a lot of your lymph will go through lymph nodes, your blood will go through hematopoietic tissues, so it helps to have this sort of mesh like filter for in the reticular connective tissue that's going to be made up of your reticular fibers. Okay, this is a picture that we've seen earlier. This is adipose tissue. So adipose tissue is the connective tissue that specializes in storage of fuel and storage of lipid. All right. So when you have a lot of adipocytes together, especially the white adipocyte, okay, it's going to have this honeycomb-like appearance. Okay. And adipocytes, they can be separated from each other by septa of collagenous connective tissue. Okay, a lot of collagen fibers put together, and you will form septa or divide your adipocytes into lobes or lobules. Okay, you can see these are one adipocyte, another adipocyte will appear empty with the nucleus pushed to the side, right? They appear empty because your lipid is already washed away during preparation of the slide. Okay, this is the white adipose tissue. Okay, unilocular. It stores lipid in one droplet. Okay, and then you have your brown adipose tissue, as mentioned earlier, multilocular, many lipid droplets, and you have a lot of mitochondria that gives off the brown appearance. Important in heat production, especially in newborn. You can see that is an example of brown adipocyte. Okay, this one here is white adipose tissue. This one here is brown adipose tissue. So all of this is your brown adipose tissue, and the rest here is your white adipose tissue, right? So you can definitely see the difference between the white adipocyte and the brown adipocyte in terms of appearance, especially in how they store their lipid. So white adipose tissue, unilocular; brown adipose tissue, multilocular. Okay. Other kinds of special connective tissue is your blood. So you know your blood, you have blood cells, your white cells, your red blood cells, and the plasma. It helps to transport fluid, gas, hormones, nutrients. Okay, and you have your, as I mentioned, erythrocyte is your red blood cell, leukocyte is your white blood cell, and platelets. Don't forget the platelets as well. But again, all of this will be discussed later in your hematology block. Okay, the different kinds of blood cells, especially the white blood cells, it's all very, you have different kinds, sizes, shapes. Okay, and lastly would be a supporting connective tissue. Okay, supporting connective tissue will have your bone and cartilages. Again, we'll be talking about this specific lecture. So cartilages, they're more flexible structures, can divide into hyaline, elastic, or fibrocartilage. Okay, it doesn't have any nerve or blood vessels to it, and it's made up of chondroblasts and chondrocytes. The chondroblast is the more immature one, chondrocyte is the more mature cell. Okay, so this is what a cartilage or especially a hyaline cartilage would look like. And then you have bone. Their bone is made up of rigid matrix. Okay, so it's very, very hard. Okay, you have some blood vessels in it. You can have either compact or spongy bones. And the cells that you can see is osteoblasts, osteocytes, and osteoclasts. Remember osteoclast here? This is a fixed type of macrophage. Okay, which is a cell of the connective tissue. All right, that is what a cross section of a bone would look like. Okay, we will be talking about this Tuesday, Wednesday. All right. Okay, any questions up till now? Okay, with connective tissue. Everyone okay?
Yes. If you have
Okay.
questions,
Okay, doctor.
Sorry, someone asking something?
if you have questions later, we can text you, right?
If you can email me, is better.
Or email you the questions.
Yes. If you have any questions, you can email me. Is that Asif?
Yes.
Yes. You can email me, no problem. Okay. So
Oh.
I will put up the slide in this channel. Okay. So if you want to look for the slide, it will be located in this channel. If you have no questions, I think that's it. That's the end of the lecture. Okay. Thank you very much.
Doctor,
Yes. Yes.
about
Yes,
adipose tissue, adipose cells. What do
Yes.
you mean uni